All right, there we go. So today we're going to be talking about solving equations that contain rational expressions. All right. So I'm going to say the same thing that I've been saying for like the last maybe week and a half, 2 weeks. All the tools that you need to do this section, you already have. You already have these tools. All right. So I think the first thing that we should do is start off with a very easy example. Okay. So first things first. Oh, sorry, wrong button. There we go. So we're going to start off with this problem. Just get out my black marker. Directions are simple. One word is solve. And we're going to solve x over 2 plus 8 over 3 equals 1/6. So remember, rational expressions, polynomials in a numerator, polynomials in a denominator. Now, rational expression is just, in my humble opinion, that is kind of like just a fancy word for saying fractions. So we're just solving problems that contain fractions. So what's our first step? When we are solving problems with fractions, what is our first step? Find the LCD. Perfect. So what is my LCD in this situation?
6.
Perfect. It's 6. Very good. All right. Now, what am I going to do with this number 6? Because this step 1, everything stems off that number right here. So what am I going to do with that number 6? Remember, we did this problem back in chapter 4. We're in chapter 14 now, so 10 chapters ago. So what do you think? What are we going to do with this 6? Crystal, what do you think?
The what?
The what? So you came a little late, didn't you?
Sorry.
That's okay.
No,
That's okay.
I'm
So this LCD of number 6, like we found the LCD. We're solving the problem x over 2 plus 8 over 3 equals 1/6. Why do I have to find the LCD?
so that you can add, so you make all denominator a 6.
Okay, so I think that's a pretty good idea, but there's an easier way to do this. Okay, so real quick, because Crystal, you're absolutely right, but this is like a question where it's like that was a good answer, but there's a better answer, and I hate those questions. You guys remember those questions where it's like choose the best answer that applies, and they're all correct, but only one is like the best. Then you start second guessing yourself constantly. So on page. Now, I know some of you may have never looked at the book, but I think it's on page 309. Nope, not 309. Maybe it's the next page, 310. Maybe it's the previous page. I know it's one of these pages in chapter 4. Ah, there it is right there. So here are our steps for solving an equation in the variable x. And step 1 is massive. Step 1 says, if fractions are present, multiply both sides of the equation by the LCD of the fractions. So that's exactly what I'm going to do. Now, if you were to use the help me answer this function within my math lab, this is what it's going to say to do, and it's correct. We're going to multiply both sides of the equation by the LCD. Okay? Now we know on the left-hand side, I have the distributive property that I can use. So this is kind of like step 2. If parentheses are present, use the distributive property to remove them. All right? So I'm going to use the distributive property first, but I'm not going to simplify anything because I want you to see what's happening. So I'm going to multiply both of these fractions by my LCD. So I get 6 times x over 2 plus 6 times 8 over 3 equals, and over here on the right, I'm just going to leave it the same for now. So the only thing I did was just distribute. That was it. Now, here is why we want the LCD. I'm going to go ahead and I'm going to take the very first fraction here. I'm going to show you what's happening. So I'm going to scroll over to the right. Now we know we're multiplying fractions. Whenever we multiply fractions, we try to simplify first. Does that make sense, everyone? So I know that 6 technically is 6 over 1. And if I really wanted to, I can break that 6 down into 2 times 3. Can anybody tell me why I decided to break that 6 down into 2 times 3?
Because you can cancel the 2.
I can reduce the 2's. Watch what happens, everyone. I have a 2 in the numerator, 2 in the denominator. 2 over 2, remember, is 1. So then I write whatever's left over. I have a 3 times x, and the x is in parentheses. If you want to leave it like that, that's fine. Or you could just write 3x. So I'm going to go back over to my problem. I'm going to copy this down directly underneath. So this simplifies down into 3x. I'm going to do the same thing with the middle fraction, the 6 times 8 over 3. Watch what happens, because I'm really trying to make a point here. Here is 6 times 8 over 3. Remember, we're multiplying fractions, so we try to reduce first. I'm going to break down the 6 into 2 times 3 again. And why did I choose to break down the 6 into 2 times 3? Can anybody tell me why? Other than Crystal this time.
We can simplify the 3.
You could simplify the 3's. Very good. And look what you're left over with. 2 times 8. So I'm gonna write exactly how that looks. So I'm gonna come back over to my problem. Just write 2 times 8. Put my equal sign. Now the last fraction. Well, that's going to be 6 over 1 times 1/6, or 6 over 6, which is really what?
1.
Good. So, if I zoom out, let me get rid of this stuff over here to the right so you're not looking at that. So if I zoom out and I look at what I've done, I got a problem that contains rational expressions. So I found the LCD. I decided to multiply both sides of the LCD and simplify. So from this step down to here, I've successfully, and with one number, removed all my denominators. I got rid of all of them. Now the problem looks like something out of chapter 3. 3 times x plus 2 times 8 equals 1. We know 2 times 8 is 16, which equals 1. I can't group anything on the left. I cannot group anything on the right. So now I'll get the variable terms on one side, constant terms on the opposite side. One minus 50, or I'm sorry, I'm moving. Look how fast I'm moving here. I'm already writing down what the answer is. I subtract 16 from both sides. 1 minus 16 is negative 15. I divide both sides by the number in front of my variable. To give me x equals negative 5. So, let's think about what's happening here. Okay? A long time ago in chapter 4, you learned how to solve equations containing fractions. In chapter 14, we're learning about this new thing, and it's really not that new, but it's new enough. And they are rational expressions, which are nothing more than fractions. It's just these fractions that we're talking about have polynomials in the numerator or denominator or both. Okay? But our method for solving that we learned weeks ago hasn't changed. Okay? In fact, with the next problem we're going to look at, okay, you're going to see that we're actually pulling everything that we learned all in together to solve something. Does that make sense, everyone? All right, so I'm going to give you one that's extremely similar to this problem to do. All right? Just so we can get warmed up here. So here's your example. Solve x over 3 plus 4 over 5 equals 2 over 15. Now, if you need the steps, maybe open up another window on your computer or use your phone or something. And it's on page 308. Okay, we ready to go over this? All right, so step 1, I need an LCD. Who got one?
15.
I agree, 15. So what I'm going to do is multiply both sides by 15. Okay? Now I distribute. I keep things very simple. I write everything out. No need to rush. All right, now from here, remember, the whole reason why you chose 15 is because it was the LCD, which means I can simplify every single denominator. So here's the way that I look at this. Because I know coming over to the right, writing this over and over again can get very... Sorry, I'm writing fast. Writing this over and over again can get very cumbersome. All right, it gets boring. You know, you're writing a lot. Here's what I do. I look at the first fraction. The first thing I will do, I will take 15 and divide it by 3. What is 15 divided by 3?
5x.
Good. 5x plus 15 divided by 5 is 3. So I write a 3 parenthesis 4. 15 divided by 15 is 1 parenthesis 2. Does everybody see what I did there? Because I went really fast. But remember, the reason why you chose the LCD of 15 is so you can simplify the denominator. So why not just do that first? Just divide. Okay? That's it. Just keep it simple. Now from here, I'm going to multiply 3 times 4, which is 12. And then on the right-hand side, 1 times 2 is 2. I will subtract 12 from both sides. I get 5x equals negative 10. And then divide both sides by 5 to give me x equals negative 2. Okay? Now, there is something that I want to review on this problem. And it's right here. Because I want to make sure that we are very, very, very explicit. Okay? Anytime that you go ahead and you simplify denominators the way that we did, you don't want to move fast. What you want to do is just write what the simplification is and then rewrite whatever's left over in that numerator. Okay? So technically, I mean, I could have said, 15 over 4 divided by 5 is just 3 times 4 is 12. Like, I could have did all that in my head. But I didn't. I chose to write it out like this. Here's why. With this next problem, you're going to see, you'll see why with the next problem is what I'm trying to say. So here's our next example. We're going to solve t minus 4 over 2 minus t minus 3 over 9 equals 5 over 18. Now here, my LCD is going to be 18. So I'm going to multiply everything by 18. Actually, let me do both sides first. Okay, so multiply both sides by 18. Now I will distribute. All right. Here's why I'm saying just be careful. Just slow yourself down. The thing you don't want to forget is that if your numerator has multiple terms, you still need to go ahead and distribute things. So what I mean by that is this. First thing I'm going to do is take 18 divided by 2. I'm going to simplify the denominator. Now I know 18 divided by 2 is 9. And all I'm going to write is what's left over in that numerator, which is t minus 4. Same thing in the middle. 18 divided by 9 is 2, so this is going to be minus 2, parenthesis, quantity of t minus 3. On the right-hand side, it's just 18 times 5 over 18, so that's just going to be 1 times 5. So now hopefully you can see that because I'm writing it in parentheses, I still got to distribute some stuff. Does that make sense, everyone? All right? So always, always, always take your time, talk out loud if you need to, move slowly, and just understand the steps that you're making. So now I'm just going to distribute the 9 to give me 9t minus 36. I'm going to distribute the negative 2 to give me negative 2t plus 6 equals 5. Now I'm going to group like terms on the left. Well, 9 minus 2 is 7t. Negative 36 plus 6 is negative 30. And that's going to equal 5. Now I'm going to get variable terms on one side, constant terms on the opposite side. So I'll add 30 to both sides. which will give me 7t equals 35. And then I divide both sides by the number in front of the variable to give me t equals 5. Any questions with that? All right. Now, here is where the fun part kicks in. Okay? We're going to look at an example that you've never done before. But you already have the tools to do this. I want you to try it on your own, and I want you to answer the following questions. So I want you to solve 8 plus 7 over x equals x plus 2. Label the solution and determine if there are, how do I want to say this here? How about this instead of determine? How about label the solution and any possible non-solutions? So I want you to label the solution and then tell me, are there any other values that I will not be able to use? So go ahead and try that. Okay, how are we looking? Anybody get an answer?
I'm not sure though. I got the -7 and 1.
Okay, how do I want to say this? I disagree with the signs of your answers, but I like the numbers, but I don't like the signs.
It's -1
Yeah,
and 7.
there you go. So I do like those two answers for the solution. And don't worry, we're going to go over the problem. Okay? But what about the second part? Are there any possible non-solutions? In other words, like, is there a number out there that I know, okay, I cannot use this one? All right, so here's what we're going to do. We're going to go back to basics real quick. Okay? Number one. What is that right there where I drew that red arrow? What is that? Anybody, just, I'm telling you, do not overcomplicate it. Just tell me what it is.
Variable.
It's a variable. Very good, Amanda. Amanda, can you explain what a variable means?
Like it's an unknown term.
I love it. I'm going to use a different word, though. It's an unknown quantity. We know it represents a number. We just don't know which one. Okay? Now, I'm going to highlight something. Can anybody tell me what I just highlighted? I mean, what is that? What did I just highlight?
Fraction.
Okay, very good. And what do we know about fractions with variables in the denominator? Now remember, a variable, like Amanda said, is an unknown, it's an unknown term, it's an unknown quantity. And I got a fraction. I'm asking you, are there any possible non-solutions? What value of x am I not allowed to have? Because remember, our goal is to find the solutions. But what number is x not allowed to be?
0.
Why?
You can simplify it.
It will be undefined.
It'll be undefined. Very good. You can't simplify it. I'll just combine your two answers together. All right? I like it. So, you got to be really careful when you are solving rational expression equations. And I'm going to write that down. We need to be extra careful when solving equations with variables in the denominator. Okay? And the reason for this is because we may end up with a 0 in our denominator. Okay? So let me show you an example of when something like that can happen. All right, I'm going to show you an example here. So I'm just going to scroll up. I'm going to let you write that down for a second. And I really want you to think about it. All right. Here's our example. We're going to solve 2x over x minus 4 equals 8 over x minus 4 plus 1. Okay? Now, there is something I'm going to say from the very, or I'm not going to do, but we're going to do it from the very start of every problem. But this one we're not. Because I want to show you where this comes into play. So, I got fractions. I need to multiply by my LCD. My LCD is going to equal x minus 4. Okay? So I'm going to multiply both sides of the equation by x minus 4. Actually, I'm just going to do this. I'm just going to multiply every single term by x minus 4. It's the same thing as saying multiply both sides. It's just, instead of me using that distributive property, I'm just going to just automatically do it. I'm going to multiply everything by x minus 4. Now, we're going to start over here on the left. We know if we have x minus 4 in a numerator, x minus 4 in a denominator, they will reduce. I'm left over with 2 times x. Middle fraction. I have an x minus 4 in the numerator, x minus 4 in my denominator. I'm left over with an 8. And then lastly, I have 1 times x minus 4. So from here, I go ahead and distribute the 1. Nothing really changes. Now I will group like terms on the left. There are none. I group like terms on the right. The 8 minus 4, I can do that. So 8 minus 4 is 4 plus x. Now I will subtract x from both sides to get my variable terms together. And it looks like I have a solution. In fact, a lot of us in the room would probably stop right here. But here's the thing. You got to be very careful when you are solving equations containing variables in a denominator. Because when you go to check your solution, look what happens. You know me. Wherever I see the variable, I'm going to put parentheses first. Then I'm going to use the answer that I came up with to substitute it in. And look what I get in that denominator. What did I get? I got a 0, correct? Am I allowed to have 0 in the denominator? So, even though we went through all this work, okay, we went through all this work, and it looks like it has an answer, is there a solution to this problem? No solution to this problem. Okay? Sorry if you can hear Artie in the background. He's dreaming right now and he's barking. So, let me repeat. When you are solving rational expressions, you're going to have to check your answers. You check them to make sure that they are valid solutions. Sometimes you're going to do these problems and you're going to get 2 answers and they're both valid. They're good. Other times, you may do it and only one of them is good. Or none of them are good. So what would be an easy way for us to actually know, even before doing this problem, what answers are not good? In other words, going back to this problem right here, sorry, I asked you to find any possible non-solutions. If you understood what I meant by that, all you had to do was look right here and set the denominator not equal to 0. And that would have told you, okay, I'm not allowed to have 0 as a solution. So if I go through this work, if I do all this work for this problem, and I find out that one of my solutions happens to be 0, I know that one's not good. All right? Does that make sense, everyone? So let me show you how to do this problem now. 8 plus 7 over x equals, what was it, x plus 2? Oops. X plus 2. We know at the very start of this, x cannot equal 0. So the first thing I'm going to do, I'm going to multiply by my LCD, which is x. So I multiply every single term by x. All right, so I get 8x plus the x's reduce, and x times x is x squared plus 2x. Now, I don't know about you, but there is something that is jumping off the screen at me right now to solve this problem. What is the one thing that I see that I'm like, oh, I know exactly how to solve this problem. I'm already thinking 3 steps ahead. What is that one thing that I see? Can anybody tell me? Like I said, there's one thing I see, and I'm already thinking 3 steps ahead. Everybody's playing checkers, and Float is playing chess, because I can see it. What is the thing that I see? I mean, you got a 25% chance of guessing it. It's either going to be the 8x, the 7, the x squared, or the 2x. So just take a guess. You got a 25% chance of getting it right.
X squared.
Why am I so excited for that x squared, Crystal? You are absolutely correct.
I don't know. I think because you can factor.
I'm going to try. In other words, you've learned how to solve equations, but you've only learned 2 types of equations. I'm putting up 2, it looks like 4. You only know 2. You know how to solve linear equations, and then you know how to solve quadratic equations. This equation that I have right here currently is quadratic because of the x squared term. And I know when it's quadratic, I need to set the equation equal to 0, factor, 0, product, theorem. 1, 2, 3 steps ahead. I'm already thinking 3 steps ahead. Like I said, everyone's playing checkers and I'm playing chess. And it's all because I know, first and foremost, I'm solving. That's what the question asked me to do. Second, I need to think about, okay, what type of problem am I solving? Is this linear or is this quadratic? This clearly is quadratic. So I'm going to set it equal to 0. So I'm going to subtract 8x from both sides first. Then I'm going to subtract 7 to give me 0 equals x squared minus 6x minus 7. See, here's the thing. B, you gave me the answers to this problem. Am I right? Okay. If somebody asked you, how did you get those answers? Or better yet, when you made this move right here that I have, because the only way to get -1 and 7, what you got is you did this. You set the equation equal to 0. If somebody said to you, and be honest, it's okay. If somebody said, why did you do that? Why did you set it equal to 0?
Because when I subtract with the x, I had the 2 terms on the left and right side, so I wanted to make it equal to 0. everything comes to the left side, and after that I factored it, and there was 1 and 7, and
Okay.
the x and 7. I don't know why I did that. I can't
Ah,
explain
see,
that.
there it is right there. All right. Here, B, you just totally gave us so much information there. All right. Your brain is moving so fast that it automatically recognized the x squared, moving everything and setting it equal to 0, then factor. Like, you did it so quickly that it's kind of hard to slow yourself down. And here, I'm going to answer your question for you. Why did you do that? Because your brain saw it was quadratic and it went like that. Okay? All we need to do is slow ourselves down a little bit and then ask ourselves, okay, why are we making this? Why are we doing this step? Okay? B, excellent job. Like, right now in my head, I'm like the happiest math guy on earth. All right? Good. So from here, we set it equal to 0. We factor. We have our techniques. How about 7 and 1? Set each one of these equal to 0 and solve. Now, I know both of those solutions are acceptable because neither of them are 0. Does that make sense, everyone? All right? So, I'm going to give you... Sorry, give me 1 second. I'm going to give you just some general guidelines on how to solve problems now. Okay? Now we are really getting into, excuse me, we're really getting into this idea of solving, okay? We were very rigid before. Like, linear, do these things. Quadratic, do these things. And that's still valid. I mean, that's not going to go away, okay? But now, like I said, we're gonna get more general in the sense that the problems that we're gonna be doing are gonna be changing up a little bit. Okay? So here are like our steps. So I'm just gonna say general steps for solving rational equations. Step 1. Identify any possible non-solutions. All right? And you already did that. You know what that's really called? Find a domain. Remember us finding domains? Take the denominator, set it equal to not 0, and then tell me what numbers you're not allowed to have. It's exactly what you're doing here. Step 2. You're going to multiply by the LCD to remove denominators. Okay. Step 3. And this is where it's very general. You're going to solve accordingly, meaning if the problem's linear, then use your steps for linear equations. If it's quadratic, then use your steps for solving a quadratic. And I'm going to be honest with you, and I'm going to write this in a different color. You may run into the situation you can run into the situation where initially the problem starts off as a quadratic. And then it'll actually convert itself into a linear equation. When that occurs, your x squared terms will actually cancel each other out. That can happen. The idea behind this is knowing what type of problem you have every single step. Okay? Now, if you really think about it, in this solve accordingly, if it's linear, there's 6 steps. If it's quadratic, there's 3 steps. So there are more steps to this than what I'm giving you. I guess what I'm doing here is I'm saying, okay, we've been through this semester. You should already have a really good understanding on how to solve a linear equation. And you should already have a really good understanding of solving a quadratic equation. It's up to you now to take those tools or those properties off the shelf and use them. Okay? Does that make sense, everyone? All right, so let's do some more problems now. Now we got everything we need. We got everything we need. So we're going to solve x plus 14 over x minus 2 equals 7x over x minus 2 plus 1. So from the very start, oh wait, I'm moving way too fast. Give you a second to write it down. Okay. From the very start of this problem, I already know x cannot equal what number? Like if I do all this work, I funnel all my work down, I know x is not allowed to be what number? Very good, B. I saw your lips moving there. 2. X is not allowed to equal 2. I know that from the very start. And how did I get that? Well, in my head, I said, I'm going to take the denominator. I'm going to write not equal to 0. And I'm just going to solve. I know x cannot equal 2. All right? So I already know that. Now, let's go ahead and let's solve this. My LCD is going to be the factor x minus 2. It's at denominator. So I'm going to multiply every single term by x minus 2. I'll write this one back. I'll write it the other way. How about this? Remember, order doesn't matter when you're multiplying. So I multiplied every single term by x minus 2. Now I'm going to simplify. So for the first, x times x is x squared. X times negative 2 is minus 2x. Plus. Now we're going to simplify the first fraction. I got an x minus 2 that I'm multiplying by and an x minus 2 in my denominator. So I know they're going to reduce to 14. That's what's left over. On the right-hand side, the x minus 2 I'm multiplying by and the x minus 2 in the denominator, they reduce. 7x. Now I distribute the 1. 1 times x is x. 1 times negative 2 is negative 2. From here, what type of problem do I have? Is it linear or is it quadratic?
Linear.
Oh, be careful, Ramzia. It is not linear. It is...
Quadratic.
Yeah, it's quadratic. It's right here.
X over 2 minus.
Yep. X to the second power makes this quadratic. So this gets away, or this shoves the I don't know why I did that, or I don't know how to do this. It's quadratic. So we already know if it's quadratic, get everything on one side, set it equal to 0. So that's exactly what I'm going to do. So I'm going to look at the left-hand side and the right-hand side. I'm going to group like terms first. It'll make my life easier. On the left, there's nothing I can do. On the right, 7x plus x is 8x minus 2. Now, I will subtract 8x from both sides. That gives me x squared minus 10x plus 14 equals negative 2. Now I will add 2 to both sides. That's going to give me x squared minus 10x plus 16 equals 0. So it's still quadratic. It's equal to 0. There's no GCF. I have 3 terms with a equal to 1. So I'm just going to go ahead and factor x and x, minus and minus. 2 numbers that multiply to get 16 combine to give me negative 10 and they're both negative. How about 2 and 8? Now, I will set each of these equal to 0. And solve. I know, and I'm going to zoom out here. I know from the very start of this problem, x is not allowed to be what number, everybody? X is not allowed to be 2. If you look right here, all my math, I came up with the solution x equals 2, but I know it's not allowed to be 2. So, I put a big X through it. There is only one solution for this problem, and that is x equals 8. Does that make sense, everyone? So even though it feels like there's 2 solutions, because it was quadratic, in reality, there's only one. X equals 8. In fact, do I want to show you that? I could show you this. It's not going to hurt us. In fact, we're going to pull out Desmos and we're going to see something. And watch this. I'm going to go ahead and just type in this equation. X plus fraction bar 14 over x minus 2 equals fraction bar 7x over x minus 2 plus 1. What do you even look like? Oh, nice. Look at that right there. What do we notice about this red line at the number 8? It crosses the what axis?
X.
The x-axis. Very good. It actually crosses our x-axis right at the number 8. That's amazing, isn't it? I mean, we learned in the previous section that when you factor something, you were finding the x-intercepts. That's exactly what we did here. We have a rational expression. And what ended up happening was we had to factor to solve it. From the very start, we knew x cannot equal 2. So the way that I'm looking at this is, when I see x equals 8, in my brain I'm thinking, if I were to graph this, the only x-intercept that this problem will have is at 8. 8, 0. And that's exactly what this looked like. Does that make sense, everybody? That's a powerful thing when you really, really think about it. Is it not? I mean, I find it absolutely... It's crazy how everything just fits. It really is. Now, I'm going to give you a problem to do. Are you ready? Are we ready? All right, so here you go. Here's your problem. I want you to solve x plus x over x minus 5 equals 5 over x minus 5 minus 7. Let's go ahead and try that. Does anybody need any help? Anybody have an answer?
-8.
Minus 8. Is that the only solution?
I got 5 as well, but 5 cannot, x cannot be 5.
Okay, so let's go. Let's solve this then. So from the very start, we know x cannot equal 5. Because if I put 5 in that denominator, I'm going to get 0. Can't have that. So my LCD is just going to be the factors of the denominator. The only one I see is x minus 5. So let's multiply everything by x minus 5. I'm going to zoom out here a little bit. So x times x minus 5 plus x minus 5 times this ugly fraction equals x minus 5 times the second ugliest fraction minus 7 times x minus 5 again. All right? Now, left to right, simplify. I see x times the quantity, x minus 5. I'll distribute. I get x squared minus 5x. I'm already thinking, set it equal to 0, factor, set each of those factors equal to 0. Like, that's how fast I'm doing this now. Because I can see these things. I see these terms. Next, x minus 5 in the numerator, x minus 5 in my denominator. They reduce. Next, x minus 5 in the numerator, x minus 5 in my denominator. They reduce. Lastly, I'm going to distribute the negative 7 to give me minus 7x plus 35. So I still got the x squared term. So I know that it's quadratic. I'm going to go ahead and group like terms real quick just to make my life a little bit easier. So on the left-hand side, negative 5x plus x is negative 4x. On the right-hand side, 5 plus 35 is, what is that, 40? So now I'm going to move everything to one side. And I'm going to move it to the side that the quadratic is contained. So I add 7x. That gives me x squared plus 3x equals 40. Now I'll subtract 40 from both sides to give me x squared plus 3x minus 40 equals 0. There's no GCF. There's 3 terms. A is the leading coefficient. So I'm going to go ahead and factor. Two numbers that multiply to get 40 combine to give me 3. One of them is positive, one of them is negative. How about x plus 8 times x minus 5? Now I set each one of these factors equal to 0. For the first, I get x equals negative 8. In the second solution, although it says x equals 5, I know from the very start I can't have that. So there's only one solution, which is x equals negative 8. And I'll just zoom out so you can see the entire problem. Are there any questions with this? All right, so I gave you the first problem where it turned out, after you multiplied by the LCD, it was linear. So you just use your steps to solve linear equations. Now I've given you 2 or 3 examples where it turned out to be quadratic. Okay? So after you multiply by the LCD, it's quadratic, which means you had to set it equal to 0, do all that stuff. But I didn't give you one where it starts quadratic and then it turns out to be linear. Okay? Now, like I said, that can happen from time to time. All right? And what I'm going to do here is I'm going to try to find one. You got to give me a second because I got to do these in my head real quick. Where it turns out to be, or initially it's like quadratic, but then it turns out to be linear. So let me see if we have one of those. Oh, I'm looking. No, that one's no good. Maybe this one, but I'm not sure. Now that I'm looking again, I don't think this one does that either, but that's okay. We're going to do it anyways. All right. So from the very start, are there any numbers that x is not allowed to be? I mean, my eyes go right here. Those two are really easy. X cannot equal what? What are you doing? Something's happening here. There we go. I think we're good. Give me the two numbers that x is not allowed to be.
5 and minus 6.
And I'll put them in order. Good. Are there any others? I mean, let's be honest, Jada. Potentially. Right there, would you agree? We're going to find out once we do the LCD. Because see, every problem that we've had so far, it's been nice. It's already been factored in everything. So, let's go ahead and factor that. No GCF. 3 terms, 1 out front. Write an X. Do my signs. Huh. Well, hold on one sec. You need to change that x squared to x squared plus x minus 30. I copied the problem down wrong. So this thing right here has to be a plus. All right. So now my factoring changes a little bit. There we go. All right. So we got a factored form of x plus 6 times x minus 5. So do I have to worry about any other solutions that will make my denominator 0? Yes or no? No, I got them all. So I know x cannot equal negative 6, x cannot equal 5. Now, let's solve this problem. Let's see what happens. My LCD is going to be x plus 6 times x minus 5. Remember, you look at all the denominators, find the unique factors, x plus 6 and x minus 5. Then you may have to raise them to a power. So you're looking at the denominators and if they repeat it all. They don't repeat it all. So we're going to multiply everything by the LCD. Now, if you just want to watch, just watch. It's okay. I'll give you time to write this down. Because this is going to look a little messy at first. But as long as you write neatly, you take your time, and you understand the technique. Finding the LCD first, then multiplying every single term by your LCD, and then you simplify. It shouldn't be too difficult. So the only thing I did here was I rewrote the problem, but I put x plus 6 times x minus 5 in front of every single fraction. And now I'm going to reduce. So if you take your time, write neatly, watch what happens. You got an x plus 6 in the numerator, x plus 6 in the denominator. We know they reduce. You got an x minus 5 in the numerator, x minus 5 in the denominator. They reduce. So you're left over with 4x. Think about that. That first term that looked really ugly, it turned out the entire denominator reduced. That's a good thing. Now, for the second fraction. You got an x plus 6 times x minus 5 in your numerator, and you're multiplying that by 2 over x minus 5. The only thing that reduces here are the x minus 5s. That's it. What's left over? 2 times x plus 6. Does that make sense, everyone? All right. Equals, now for the last fraction, you're still multiplying by that LCD, but the only denominator is x plus 6. So that's the only term that reduces. You're left over with 1 times x minus 5. So you started with something that was very ugly, very tedious, a lot of writing, and you turned it into a problem that's actually really simple to do. Right now I'm looking at it, I'm scanning from left to right. All my variables are raised to the first power. So this is linear. So I see parentheses, I'm going to distribute. I get plus 2x plus 12 equals x minus 5. I look on the left, can I combine any like terms? Looks like it. 4x plus 2x is 6x plus 12. I look on the right, there's nothing I can combine, so I leave it like that. Now, I'm going to get my variable terms on one side, constant terms on the opposite side. So I'm just going to subtract x from both sides. I'll do that first. So that gives me 5x plus 12 equals negative 5. Now I'm going to subtract 12 from both sides. I get 5x equals negative 17. And last but not least, I divide both sides by 5 to give me x equals negative 17 over 5. Nobody said these answers have to look pretty. The only thing I'm concerned with is that a valid solution? Well, it's not negative 6 and it's not positive 5, so I feel pretty confident with my solution. Does that make sense, everyone? How are we looking? Are there any questions? Are we sure? All right, going once. Going twice. All right. Well, let's see here. It's 10:30.